look at the Lewis diagram, what does it look like? What kind of organic compound is that? It's a COH, so it's an alcohol. This is called propanol because it's a 3-carbon alcohol. Propanol. The Lewis structure doesn't have to be accurate in terms of the three-dimensional structure. So we're going to try to draw this accurately. When you look at it, what's the first carbon? First carbon is tetrahedral EPG and tetrahedral Mg because we have 4 bonded, 3 hydrogens and 1 carbon. When we have a carbon chain, then we do it like this. Draw it like this. Draw a carbon here. And then this is tetrahedral. So this is our starting point here. And so up here is going to be we'll put a hydrogen here, hydrogen here, hydrogen here, and then we'll just extend the chain this way. So that's our first carbon, tetrahedral, tetrahedral. What's the second carbon? Tetrahedral, tetrahedral. So what we're going to do is we're going to draw one V going up like this. So it's going to create this zigzag pattern. And so we'll put the carbon over here. So if we have one V going up, then the other V is going to be flipped over and then twisted 90. And so we'll flip it over, twist it 90. That means we're going to have a wedge coming out like this and a dash going in like this. Do you see it? And so this would be tetrahedral. 2 in the plane, 1 coming out, 1 going in. 2 in the plane, 1 coming out, 1 going in. It's tetrahedral. And then we'll put 2 hydrogens. So the hydrogens go on the same side. No, they don't go on opposite sides. Okay, then we want to continue the chain. To continue the chain, what we're going to do is we're going to zigzag it. And so the zigzags are going to be the 2 in the plane. So this carbon's going to have 2 in the plane like this. It's going to go to oxygen here. If it has 2 in the plane, then, well, this is a V like this. So we'll bring a V up here and then twist it 90. And so what we're going to end up with is we're going to end up with a wedge coming out like this and a dash going in. And here we're going to throw in 2 hydrogens like that. So we have the wedge dash. Now it's the same. We're going to continue the zigzag pattern. So the hydrogen is going to go up like this. And so this zigzag is entirely in the plane of the board. It doesn't have to be because these bonds actually can twist. And so it can, but we can flatten them out here for our drawing. And so what is the oxygen? Oxygen is, what's the EPG? Tetrahedral. What's the Mg? Ben. So this is tetrahedral Ben. So tetrahedral means we'll put the bonds in the plane and then the lone pair. One lone pair is going to wedge out. A wedged out lone pair is going to just be solid. And then one lone pair is going to go in, and that'll be dotted. And so what this is trying to show is it's trying to show that we're going to have a wedge coming out that's going to be the lone pair here, and then the dash going in, which is going to be the lone pair here. Do you see that? But we don't show. The wedge represents a bond, so it's not a bond. Yeah, and so what I have is like this. I have this in the plane of the board, and this is like this, sticking out. One is sticking out this way, and one's sticking in.
The other one's down.
Yeah, and so tetrahedral is, you think of two V's. So we have one V like this, and then we'll make another V like this. And the second V is going to be twisted at a 90, like this. And so this is what I'm looking at here. I have one V in the plane, and the second V here is going to be twisted at a 90. So one's sticking out, the other's sticking in.
So if you run it, that's down.
Yeah, if you run before down. And so you got to just make sure that works. And so this is propanol. Propanol, that's an alcohol. Try number 24. Number 24, let me just draw the Lewis structure for that one. This is propanoic acid. The Lewis structure for propanoic acid is a CH3, and and then a CH2, and then a C, O, O, H.